DC generation. DC power is required by most aircraft systems for control, operation, and indications. There are three sources of DC power: DC transformer rectifier units, or TRUs, DC batteries, external DC power. DC TRU distribution. 5 transformer rectifier units are installed in the unpressurized equipment compartment in the nose of the aircraft. Each TRU converts AC to DC power. The source of AC power for each TRU is identified on the DC synoptic page. The 28-volt DC TRUs are each rated at 100 amps. The 5 TRUs are identified as follows: TRU-1, TRU-2, Service TRU, Essential TRU-1, Essential TRU-2. DC power storage. 2 24-volt DC nickel-cadmium batteries are installed in the aft equipment compartment. The batteries are different sizes. The APU battery is the larger of the two and is rated at 43 amp-hours, while the main battery is 17 amp-hours. The APU battery provides start power to the APU, in addition to supplying power to the DC buses. Battery charging. 2 battery chargers are located in the aft compartment, one for each battery. Each battery charger is powered from an AC utility bus. It is monitored for temperature and cell imbalance. This information is used to control the charging operation. Battery charging is automatic. ICAS messages are provided should a battery become unavailable or a battery charger fault occur. DC power indications. Indications of voltage and load are provided within the TRU outlines. The batteries are also represented on the ICAS DC synoptic page. Battery voltage and load are displayed in the battery blocks. TRU bus distribution. The 5 TRUs supply DC electrical power to the DC buses. TRU-1 supplies DC bus 1 and DC utility bus 1. TRU-2 supplies DC bus 2 and DC utility bus 2. Service TRU supplies DC service bus. Essential TRU-1 and 2 supply DC essential bus and battery bus. DC buses 1 and 2. DC bus 1 is found on circuit breaker panel 1, and DC bus 2 is found on circuit breaker panel 2. DC bus 1 and 2 carry a large share of the DC load. DC utility bus. DC utility bus 1 is found on CB1, and DC utility bus 2 is found on CB2. These buses power reading lights in the passenger compartment and are non-essential. When TRU-1 or 2 fails, the associated utility bus is shed. DC service bus. The DC service bus is found on circuit breaker panel 2. The DC service bus energizes the navigation lights and provides lighting in the passenger cabin, toilet, and galley. The DC service bus is normally powered by the service TRU. When the service TRU is unavailable, the bus may be powered by the APU battery direct bus. DC essential bus. The DC essential bus is found on circuit breaker panel 4. The bus is normally powered by essential TRUs 1 and 2. As its name implies, this bus is essential to flight. In the event of both essential TRUs failing, the service TRU can act as a source of backup power. If the service TRU is not available, the aircraft batteries will power the bus. DC battery buses. The DC battery bus is found on circuit breaker panels 1 and 2. When AC power is not available and the battery switch is selected on, the bus is powered directly from the APU battery direct bus and main battery direct bus. When AC power is available, the battery bus is powered directly by essential TRU-1 and 2. The battery bus can also be powered by the service TRU. DC tie system. 3 DC tie contactors provide an alternate method of powering the important DC buses when the associated TRU fails. The DC tie system operates automatically or can be manually selected by the pilot. The DC tie system on the DC electrical page is indicated by tie 1, tie 2, and essential tie. The broken lines represent a connection between two contactors. When one contactor is closed, the other contactor is open. If TRU1 fails, the DC tie 1 contactor automatically closes, allowing the service TRU to power DC bus 1. To reduce the total electrical loading on the service TRU, DC utility bus 1 is load shed. The supply contactor to the utility bus is opened when the tie 1 contactor is closed. Failure of TRU1, closing of the DC tie 1 contactor, and load shedding of the DC utility bus 1 are indicated by the white closed switch light and the status message DC tie 1 closed. The DC tie system provides automatic backup power to DC bus 2 when TRU2 fails. When TRU2 fails, the DC tie 2 contactor automatically closes. With the DC tie 2 contactor closed, the DC utility bus 2 is load shed. Closure of the DC tie 2 contactor is indicated by the closed switch light and the status message DC tie 2 closed. The DC essential bus and battery bus are normally powered by essential TRU1 and essential TRU2. When essential TRU2 fails, the DC essential tie contactor can be manually closed to allow the service TRU to provide a second source of power to the essential DC and battery buses. The backup protection is not automatic. Main and APU battery direct buses. The main battery direct bus and the APU battery direct bus are hot buses. These two buses are powered directly from their respective batteries, as the word direct in the bus name suggests. The main and APU direct buses are located in the aft equipment bay and are not accessible in flight. They power minimum equipment needed for operating on the ground and in flight. When the aircraft is on the ground without AC power, selecting the battery switch to on connects the battery bus to both of these direct buses. When the battery bus is powered, the APU can be started. Similarly, if all AC power is lost in flight, the essential bus and battery bus are powered from the batteries. External DC. An external DC power card may be used to power a portion of the DC distribution system. It may also be used to provide DC power to the APU starter. The external DC receptacle is located on the right aft fuselage, below the number 2 engine. The DC buses that may be powered by external DC include APU battery direct bus, main battery direct bus, battery bus, DC emergency bus. External DC switch. An external DC switch light is located on the flight deck electrical panel. The green available light illuminates if DC power is connected and of good quality. The white in use legend illuminates when the external DC switch light is actuated. The external DC symbol, voltage, and current are also indicated on the DC synoptic page. As previously mentioned, the DC service bus is powered from its own service TRU. The DC service bus supplies power to the navigation lights and the passenger cabin. On the ground, to assist in aircraft towing and passenger cabin cleaning, the service bus can be powered directly from the APU battery. To power the serve bus, the DC service switch on the electrical power services control panel is selected on. Note: the APU battery may be depleted if the DC service switch is left in the on position. DC emergency bus. The DC emergency bus is found on the lower section of circuit breaker panel 1. This bus powers the following emergency equipment: fire extinguisher 1, left and right engine; fire extinguisher 2, left and right engine; APU fire extinguisher, A and B; fuel shutoff valves, left and right engine, and APU, hydraulic shutoff valves, left and right engine. It is a hot bus, powered directly from the batteries. The emergency DC bus is not normally displayed unless a problem exists. The bus is provided with two sources of power, the battery bus and APU battery direct bus. Should one or both of these power feeds be lost, the DC synoptic page will display the DC emergency bus.